Hello, this is Harun Heather, and in today's video I will walk you through a Python script that processes historical precipitation data and calculate the standardized precipitation index, which we used to call SPI, for various time scales. Like we used to calculate it for 3 months and for 6 months, 9 months, and 1 year, 1.5 year, 2 years. So actually, before going towards the scripts, I think I can introduce a little like why we need SPI. The standardized precipitation index actually is a widely used tool to monitor drought by evaluating precipitation pattern over specific period of time. The script actually here I will show you. It's a Python based script, so it has several sections. I can show you how I arrange the data before processing. So this is a data sheet. You can see here the first column representing the year, starting from 1901, and it's almost until 2023. This is the available climatic data. However, there are several months in the next column which we need, like January, February. Depend on the first column is January, second February, and the number of columns it will be in the sequence until December. We just need these 12 columns, and the first column is number of year. So it will definitely depend upon the number of year the data you have. Doesn't matter if you don't have data for the all 123 years. Maybe you can just process for 10 years depending on the availability of your data. So these are actually the seasonal. We don't need these. It's automatically calculated. Calculation will be done from the these 12 columns, because for SPI we only need monthly data for these codes. So you can see the name of this file, Alvar data sheet. So this sheet is located in the folder where the file is located. Definitely it's the main folder where the SPI file code file is located. In the same folder is these files. All of these files are located. So you need to remember the sequence which I used in this code. So before proceeding to the Excel file, I may introduce a bit about the libraries which I used. I used pandas, NumPy, and Matplotlib. So this Matplotlib is just for plotting, whereas NumPy and pandas are calculation of statistical parameters. Like for pandas, I actually handle for the handling of data we use pandas, and for NumPy we use for mathematical operations. So going to next, maybe you can see after loading the data set from the 10 station, depends on the availability of station. It's not mandatory to use all 10. You can just use 1, 2 or 3, however how many depend on your availability. Then next is how to calculate SPI. So we need to define data frame and time scale. So time scale is we already discussed, like 369. We have to choose time scale and the data frame. So as we noticed, the data is from first column is the year, and the next 12 columns are the months. So I index the data into, like you can see here, this one, it means before comma there is no range. It means it will consider all the available rows. So if your data rows are 10, it means it has 10-year data, so it will automatically take the 10-year data. Whereas this column 1 to 13, it means the starting year and the ending, starting month and the ending month. So index 1, it means indexing actually start from 0, 0, 1, 2. It means if I'm using 1, it means it's the column number 2. So moving forward, so at least I think until here it's everything is clear, like how I uploaded the data to calculate SPI at different time scales. So moving forward, using the precipitation column, this one, the data, exactly the data, and then you can see that the current year and the previous month, which you need for the time scale, like the first index actually I told you is starting from 0. So it means the 0 means the first index means the first index is 0. So it means that it's actually the first column. So here in the function, we can look at the function which actually calculate the SPI. Like this function actually calculate the SPI. We are calculating SPI using the manual method, not the exactly the available package from Python. We are using the manual way. So this function is actually the heart of the script. The function calculates SPI, which takes a data frame and a time scale as an input parameter. It calculates the rolling sum of precipitation over the specified time scale, like a 3 months, 6 months, and then calculate the SPI using a standard score or z-score formula. So the z-score is computed by subtracting the mean of rolling sum and dividing by the standard deviation. So you can see, first we have calculated the rolling sum, and then we have divided the rolling sum with the standard deviation here. So after calculating the standard deviation, this process will actually be done for each year of the data set, like all of the number of rows. Then furthermore, we use the looping method, looping through all the stations. So it is not just for one station, so it actually calculates the looping. So the main loop process is process all the files generated by and SPI plots for each time scale. For each time scale in the time scale, a new figure with subplot is created. We then loop over each district file and calculate the SPI for the specific district using the calculate SPI function. So here you can find it's the plotting method. 5 rows and 2 columns. Yeah, I will show you the plot later. So grid subplot, it means the figure size should be 25 by 25. It's a square based figure. You can modify this size depending upon your need. Also you can modify, this is the number of rows and this is the number of columns, so you can modify, like if you have 6 stations, you can change this to 3, and this is 2, like each there will be 3 rows and 2 columns. So that sheet name is sheet 1, so it's the looping function. Yeah, there is another thing we need to consider, like some of the data which I previously opened has zero values, like there's no data. It can be the missing data, there's no value for that month. So if it has 0, the SPI might not be calculated, like it will skip that year. So instead of skipping the whole year just because there is no value or missing data for 1 month, we can change the missing data with missing value like 0 with 0.001, or if your data has NA values, you can replace NA values with 0.001. So see, the first year is 1901, so it means I am using from 1901 till end, and yeah, then it's just a plotting and the looping function. You can see that how to tell the number of panels, the font size, how about the bold, non-bold, you can change these values, the y-axis label, and this is all the plotting function, which is not quite important to discuss as the video is getting a little bit longer. So here you can also see there are some lines to a horizontal line for SPI categories. You can also you can plot these lines, or you can also avoid these lines. This is just to beautify the plot. So here, like the next is the it can be saved. You can see here SPI timescale all district.png. It means there will be several figures for each time scale for all districts. Like for instance, time scale is 3, so there will be one figure showing SPI-3 for all 10 districts. The number of districts you have, and then dot per inch is like 600 is the medium. You can increase the quality by changing this DPI to maybe 1000 and more. So let me plot this one. So it will actually run the code, and then it will plot all the data in multiple figures. So it will not show over here. I will show you maybe if I go over here, and my code will run in this folder. Let's see. So here there's no such kind of figure at the moment. So let's suppose if I run this code, so you will see SPIs like SPI-3, 6. Yeah, see, all plots saved as separate PNG file with enhanced styling. So let's see how the plot look like. Yeah, these are the plots. So it's SPI-3, this one. Yeah, in this figure you can see I depend on the arrangement of my station names. First one is Alwar, then the Jaipur. Let's see here. Yeah, see, first one is Alwar, then Jaipur. If you want to change the location, you can just replace the sequence of this file. Maybe you can put Bharatpur in the top first line if you want there to be the first line, or maybe the second, wherever you want. It's depend on the sequence of this file. So here see there are some other lines, red line to represent different SPIs. So this is SPI-3 of all these 10 stations. Similarly, this is SPI-6 of all these stations, 9, and similarly 12, 24, and 36, and also 48. So you can see these trends from 1901 until 2023 in different SPIs like SPI-3, 6, 9, 12, and others. So I hope this video will be useful for you for in future research about if you're working specifically on droughts, then definitely this will be very useful. Instead of calculating all this in Excel and spending a lot of time for each of them, and might not be even possible. So I will suggest you to use a Python script. I mean, you can use this script of mine to calculate your SPIs in this way. So yeah, if you like this video, you could subscribe to my channel, and if you have any further questions, my WhatsApp number and the other my accounts such as my ResearchGate, Facebook, email, all of the contact information is also already provided in my channel. You could go to the channel and you can contact me through WhatsApp or any other social media. Then if you have any further questions, you can contact me, and if you need some help or anything, you can also contact me for that. Thank you for watching. I hope it will be useful. Have a good day. Bye bye.